Recording progress.
This video is also for geometry. I'm going to go ahead and go through the homework that we did in class today, covering section 1.6. I believe we finished in class. If not, I asked you guys to finish it for homework. So just hopefully it understands. So come to class with any questions if you don't understand something. All right, so the first one, you're just doing what we did in our notes earlier. If the figure is a polygon, classify it by its number of sides. If not, tell me why. Then you classify any region formed by the closed figure as convex or concave. So you're going to tell me what kind of polygon it is based on its side, and then you're going to tell me if it's convex or concave. So number 7 is a polygon. It's a weird one, but it's all line segments and they each meet at a vertex of some kind. So oh my gosh, I love Word. Okay, so number 7 is, and it has how many sides? 1, 2, 3, 4, 5, 6, 7. 7 sides. So that's, I know, lovely. I have to number them. I always forget where I started. So a heptagon. And what else? Oh, convex or concave. Well, you can see here that we could draw from this vertex to this one, and it's outside of the set, or we could do one there that's outside the set. So there's a couple of differences. This one, part of it's outside the set. So this is definitely concave. All right, number 8, not, so no or not a polygon because it's not closed. The two parts of the definition that are important is it's a closed curve with no curved sets. So closed, no curves on any of the sides. Number 9, also not a polygon because it's not made up of line segments. So no, I'm going to say no sides, but it's that one has no sides at all. Or you could say it's not all sides. Okay, number 10, we have a polygon. It's got 3 sides, so that's a triangle. And well, you actually can't draw, triangles are always convex. They don't have enough sides to be concave. Number 11 is also a polygon. It's got 1, 2, 3, 4 sides. So it's a quadrilateral. Quadrilateral? Yeah. Polygon would be weird. I don't know. My brain, I'm done for the day for sure. So this one is a quadrilateral and it is concave. That kind of bottom left side caves in. And then number 12, we have all sides. I've got one here, one here, one here, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 9 sides. So a nonagon. And that's oh, wait a minute. It tricked me. Sorry, I'm definitely done for the day. There's the problem with this one. This one is not a polygon because it crosses over. It has to be a simple curve made of line segments that is closed. So this is not a polygon. I'm sorry. So no, not a polygon because it's not a simple curve. Okay. You will notice on the sheet that I sent home or that we worked on today that yours is going to look a little different than mine because I realized that I made a mistake when I made the worksheet. So The number 14 actually applies to the picture that you have on your paper, which is what I have right next to it here. 15, A through E, y'all don't have that picture. So just do your best to draw that circle with the center X and points A, B, C, and D with the appropriate lines. And I will be going over it in class tomorrow for the other ones that were here. So I do apologize for that. Number 4, name 5 diagonals that have C as an endpoint. I'm going to show these, and I will name the first one just so you can see the name notation, but you should be able to do these no problem. Diagonals all run from, they start at point C, and they are any non-adjacent vertice. I always get a little wonky from this point on. Any line segment whose endpoints are C and another non-adjacent vertice. So we would say that's CA, CH, CG, CF, and CE. And that's 1, 2, 3, 4. Yeah. Okay, so you would name this like CA and then the line segment over the top. And then that same notation for the other 4. All right, so for number 15, match the notation with the correct term. They may have more than one answer. So XD, you can see the center is X. So XD is our radius. DC, it does not go through the center, but it does go from one end of the circle to the other in a straight line segment. So that is by definition a chord. X is our center. So that's number Roman numeral 2. D, we're looking at the arc AD. So right here. And because of that curve at the top, so that's 1. And then BD is our diameter. But a diameter is also a chord. So this is the only one that has 2 answers. It's both the diameter and the chord. And that's it. So that makes a lot more sense. Excuse me. Okay, so we have our other figure here that we're going to use for exercise 17 through 20. Name the circle in this figure. So it's just making sure that you remember the circle notation, which, oh, I'm so bad at this. Circle notation is the circle with the center point in the middle and then the name of that center point, so C. Name 3 chords. I have LM. Remember, chords just have to go through the endpoint LM, AT, and XY. And then 5 radii. So radii just means that they start at C and they go to the circle's perimeter. So we have this one, this 2, 3, 4, and 5. If I were to name those, I would have CX, CA, CY, CP, and CT. All right, and then name 2 arcs. We obviously have many more than just 2, but you could pick any combination of XL, LA, AM, MY, YP, PT, or TX. All of those are arcs. So pick any of those, either this one, this one, this one, this one, this one, this one, this one. So you have what? 1, 2, 3, 4, 5, 6, 7. Forgot where I started. 1, 2, 3, 4, 5. Yeah, you have 7 different arcs. The important thing to note is just to make sure that you notate those correctly. So I'm going to actually put mine over here so I have room. I'm going to have LA because that's fun. And TP. Those are 2 of the 7 that you could have. Just make sure you have that somewhat curved little semicircle symbol on the top. Okay, for 21 through 23, name the 6 triangles. So again, with triangles, you can start with whatever point you want, but you need to, just like any polygon, you need to move either clockwise or counterclockwise. So for example, triangles, we always notate it with a triangle symbol. So I have triangle ABC. You could also call that triangle BCA, CBA, ACB, whatever. Just you label it by the vertices and you go either clockwise or counterclockwise consecutively. We also have triangle ACD. We have triangle ADE. There's 3. I have the big guy, ABE. That covers the whole thing. And then I also have these 2 that kind of overlap a little bit. Let me just show you. So I have BAD, that's one triangle. And I have CAE. Those are the last 2. So again, we can name them however we want. I'm going to say triangle BAD. That is always fun. And then triangle CAE. And there's our 6 triangles. All right, name all the angles except straight angles using the shortest possible notation for each. So we have this angle here in the corner. Now that one, the shortest notate, there is no number there, excuse me, so I have to use the name. Remember, the vertex goes in the middle of the name. So that one is angle ABC or CBA, that's fine too. And then of course we have angle, I'm gonna go ahead and get the other corner as well, AEB. That's this one over here. And then I'm going to get the big angle at the top. That's like, wait, where's my, like this bit right here. It covers the whole thing. So that would be angle BAE. They're supposed to be semicircles, semicolons. Okay, so I've got the main ones. It looks like for the most part, I'll use all of those interior angles with numbers. So that'll be easier. Let's get those out of the way. So angle 1, angle 2, angle 3, angle 4, angle 5, angle 6. I did not give y'all enough room. Angle 7. I'll go down here. Okay, so I got all of those little inside ones. The only one I'm missing, let me change colors here. We also have this angle, this angle. That's not helping. Let me make that a different color. We'll do this ugly purple thing. That one. 1, 2. I got the little ones. I think that's probably it. That's all the angles I see. Okay, so that would be that kind of teal turquoisey one that I have is angle BAD. Notice it matches the name of my triangle up above too. And then I also have angle CAE. I think that's all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 7, 8, 9, 10, 11, 12. Yeah, I think that's all of them. There's a bunch. And that is an absolute mess. Clean that up. Okay, what side of the largest triangle is opposite angle B? So if we want angle B, that's this guy right here. And I guess I could have named that B. Nothing else was on that one. Oh well. So the largest, what is it? Largest opposite side. So the largest triangle is BAE. So the opposite side is this one right here. So that's line segment AE. Side. Okay, is that? Let's see if I have more. I do have more. Okay, let's keep going. Perimeter, right? Perimeter and equations. Okay, so find the perimeter of each polygon. So for 39, the fact that the left and right sides are labeled or with the variable A and the top and bottom are labeled B, that is telling you that these two sides are congruent and these two sides are congruent, but they are not congruent all the way around. So to find perimeter, it's there's two, it's pretty much A, come on, A plus B plus B. So we can go ahead and simplify this to 2A plus 2B. That's the closest we can get. We don't know what A and B means. So that is the perimeter of this. So I would write that as an equation. P equals 2A plus 2B. All right, for number 40, you can see that every single side has the exact same measurement. So this is equilateral. When they are equilateral, that means that we can, excuse me, we can take perimeter equals the number of sides times the length of the side. I know that the number of sides is 1, 2, 3, 4, 5, 6. So that's 6 times the side length, which is 4m. I don't know. I wonder if that's meters. We'll just say that's meters. So that's a unit, not a variable. So yeah, okay, so we're good. So this is 6 times 4. So the perimeter is 24 meters. So we have an exact answer for that one. And the last one here, we have all variables, but you'll notice each side has the exact same variable. So that means that this one is once again equilateral. All the sides are the exact same length. And I have 1, 2, 3, 4, 5, 6, 7, 8 sides. So perimeter equals the number of sides times the length of the side. And so that is, what did I say? 8. Oh my goodness. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8. And then the side, each side is side length C. That's the closest we can get. So the perimeter equals 8 times C. Okay. Write and solve an equation to answer each question. How long is each side of a regular quadrilateral if its perimeter is 72 meters? Okay, first off, we have regular. That tells me that all of the sides are exactly the same length. And we've been told that it is a quadrilateral, which means that it has 4 sides. So regular means all the sides are the same length, and quadrilateral tells me that there are 4 sides. 4 equals n, I guess, the number of sides. And then s equals x. We don't know what that side length is, but we know that there's 4 of them. And we know the perimeter. So our formula here is perimeter equals the number of sides times the side length. They've told us that perimeter is 72 meters. So 72 equals the number of sides, 4, times the length of each side, which is x. And then we just solve for x. We divide by 4. We get x equals, what is this? 1 time, carry my 3, 4, 18. And then this is in meters. So be careful with word problems. If you have a unit, use it. So each side is has length of 18 meters. Okay, find the length of each side of a triangle whose perimeter is 22 inches. If side A, oh, this is one of those. Okay, hold on. I'm just going to draw a triangle. We're not going to worry about being to scale at this point. We know that its entire perimeter is 22 inches? All right, side A is twice as long as side B, and side C is 2 inches longer than side A. So we're just going to go side A, side B, side C. Okay, so side A is twice as long as side B. So that means that side B twice as long as side B. So A equals 2B, not to B, okay. So A is twice as long as B, so that means that A is equal to whatever B's length is times 2. And then side C is 2 inches longer than side A. So that means C equals 2B plus 2, the 2 inches, because I've already defined A as 2B. And so C is 2 inches longer than A. So I take the 2B plus 2, and that's side C. Okay. We also know that the perimeter is equal to the length of side A plus the length of side B plus the length of side C. So we can plug these in. I know my perimeter is 22. I know that A is 2B. B is whatever B is, so 1B. And then C is 2B plus 2. Yeah. There's A, there's B, and there's C. Hopefully we're all clear on what's going on. So at this point, I've got like terms. So I've got all of these guys. Let me change all of these guys here. I can combine these because they all have the same variable. So 22 equals 2 plus 1 plus 2 gives me 5, 5b plus 2. And so at this point, we can just solve it. I'm going to give myself a little more room. So 5, also I'm going to switch it. 5b plus 2 equals 22. Subtract the 2 from both sides, and I get 5b. I hate that variable. It always looks like a 6. 5b equals 20. And then when you divide both sides by 5 to get b by itself, you get b equals 4. And this is in inches. So if b is 4 inches, that's my first. A, running out of room, is 2b, so that's 2 times 4. So A equals 8 inches. And C is A plus 2. That's 8 plus 2. So there's A, B, and C. So A is 10 inches. B is 4 inches. Obviously not scale. And C is 10. We're done. Okay. Solve and express answers to the nearest tenth. Find the circumference of a circle with a radius of 7 centimeters. All right, so we want this circumference formula. Circumference equals, let's see, it's pi times diameter, or we have radius here. So this is 2 pi r. I know that r is 7, so it's 2 pi times 7. For an exact answer, we want this to the nearest tenth, but the exact answer is 2 times 7, which is 14, so 14 pi. But if we want that approximately to the 10th, then 14 times pi is 43.98. That's my 10th place, so that's going to be 44.0. Keep the 10th place because we head around. This is insane. Find the diameter of a circle with a circumference of 110 centimeters. Okay, so now they gave us the circumference, we find the diameter. C equals pi times the diameter. And I don't know the diameter, so I'm going to divide the circumference by pi. So my formula is diameter equals circumference divided by pi. That is 110 divided by pi. Here's my exact. And then if we plug that in, 110 divided by pi is 35.014, so 35.0 centimeters. All right, find the circumference of a roll of tape whose diameter is 5 centimeters. So again, they gave us the diameter. So circumference equals pi times the diameter. So it equals 5 pi. There's our exact, and then if we plug that in, 5 times pi is going to be 15.7. All right, I think, yep, that does it. All right, so that's everything for section 1.6. So just mark on your homework if there's anything that you've watched the video and you still are not sure what happened, make a note on it, and so you can ask me when you are in class next. And I hope you guys feel better soon. Thank you.